All right. So today we're picking up where we left off before. Before we were talking about graphs, velocity graphs, and what those look like. Today we're going to talk about equations, and then we'll get into some calculator work as well. Okay. First question says a ball is dropped from a height of 100 meters. So we've got our ball right here. We're dropping it. Its height is given by this position equation, S of t, where S is in meters. Question A says find the average velocity for the first 2 seconds. Average velocity. Okay, sometimes we lose sight of what that is. So far, we've only seen the word average one other time. What phrase did we hear when we heard the word average before? Average rate of change. Average rate of change. What did average rate of change mean? 2-point slope. What am I going to find the slope of if I want to get velocity? Slope of position. Good. And so to find this, I want to find the slope of position. And what do I need to do? I need to find position at 0 and the position of 2. If you find those two things, then you can find the 2-point slope. Do that now. Go. Oh, we are plugging in. You take 0, you plug it in. If I plug in a 0, that's easy. It's 100. If I plug in 2, no, actually, I have to test math skills. 2 squared is 4 times negative 16 is negative 64 plus 100 is 36. There's my 2 points. Now I'm going to do slope. So if I'm doing slope, it is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I get negative 64 over 2, or I get negative 32. It was in meters, and we just found slope of it, the derivative of it. So what would my units be now? Meters per second. When we take the slope, you add a time unit to our denominator. That's what this 2 and 0 represented. That was time, negative 32 meters per second. That is the average velocity during that time period. Okay? Average velocity, 2-point slope. Now it's asking me to find the instantaneous velocity. Instantaneous. When we heard instantaneous, that's at a single moment in time. What do we do in calculus if we want to find an instantaneous something? Derivative. Okay? If I want to know instantaneous velocity, I'm going to find the derivative of position. That's what velocity is. The derivative of position is velocity. Okay? So for here, we're going to say what v of t is. That's our derivative. Derivative of negative 16t squared. Negative 32t. What about the derivative of 100? 0. Negative 32t. That's my derivative. Great. I got it. Then I want to find it at 2. So then I take 2 and plug it in. You take 2, you plug it in. I get negative 64. That is velocity. So what do you think my units are going to be? Still meters per second. Okay, meters per second. We found it differently, but the units are still the same. When we take the derivative, we added a time unit to our denominator. It was in meters, so now it's meters per second. Good there. Part C says find the acceleration at t equals 2 seconds. Acceleration at t equals 2. What do I need to do with velocity if I want to find acceleration? Derivative. So I need to write that down. If someone was grading my paper, they need to see that connection that I'm making. Okay, so I'm going to say the derivative of velocity is acceleration. I need to make that connection. V prime equals a of t. And now I'm going to figure out what a of t is. All right, so what's my derivative? Derivative of negative 32t. What would the derivative of negative 32t be? Negative 32. That's what acceleration is. That's my equation. And so now I want to find acceleration at 2. So my acceleration at 2 would be negative 32 because there's no number to plug in. It's just negative 32. What would my units be? It was meters per second, and I just found the derivative. So now my units are going to be meters per second squared. Okay, we take a derivative, you add another time unit. It's a second derivative, so there are 2 time units in our denominator. Questions on C? Pretty straightforward. Labeling stuff was kind of the key out of everything that we just did there. Okay, number 7 kind of puts it all together here. We get a little bit more tricky. Find the velocity. That's our ultimate goal. Figure out what the velocity is when acceleration is negative 2. Take a second with your neighbor for a second. Just come up with a game plan. I can tell you what to do, but I want you to think about it for a second. Talk with your neighbor. What do you think you got to do here? We have a good game plan here. What are we going to do to find the velocity when acceleration is negative 2? Anybody at least got a first couple steps? What do you think, Alex? Okay, so we're talking about acceleration. So if we want to find acceleration, what am I going to have to do with this position equation? I'm going to take a derivative and then do it again. So let's find that. Okay, we're going to find the derivative s of t, so s prime of t, which would be velocity. I'm labeling stuff. Okay, so let's do that. I'm going to multiply by 3, so 3/12, or 1/4 t cubed minus 6t minus 4. Just some good old power rule stuff there. Multiplied. I'm going to, t squared. Good power rule stuff. Multiply by my exponent, subtract 1 from my exponent. Multiply by my exponent, subtract 1 from my exponent, and then minus 4. Okay, that's velocity. My job is to find the velocity when acceleration is negative 2. Well, I found velocity, but I got to know when acceleration is negative 2. So what else do I need to do now with this velocity equation to figure out when acceleration is negative 2? Do another derivative. I got to find acceleration. Okay, so if I want to find acceleration, I want to find s double prime of t, or the derivative of velocity, which is acceleration. You don't need to write all of those, but you need to somehow link those together. So I'm going to find that derivative. The derivative here, multiply by a 2, so it'd be 1/2 t minus 6. Finish that from there. Talk with your neighbor. At this point, see if you can figure out the rest of the way. All right, so what next? We've got our acceleration equation. What do we do from there? What do you think? Good. This word is doing a whole lot of work here. When you see the word acceleration is negative 2, that's telling you what you need. Okay? If acceleration is negative 2, that means that I need this thing, this acceleration equation right here, to be equal to negative 2, because acceleration is negative 2. Not plugging in, but I'm setting it equal to. Okay? We're going to solve it from there. So 1/2 t, I'm adding 6 to both sides. So I get 4. How do I get rid of that 1/2? Multiply both sides by 2. So that cancels. T equals 8. We just figured out the question when the acceleration is negative 2. When is the acceleration negative 2? When my t equals 8. Now that I've gotten that, what do I want to do if I want to find the velocity when that is true? Plug it in. I'm going to find v of 8. Because I know when acceleration is negative 2, I'm going to plug in 8 now to find my answer. Okay, so I'm taking 8 and plugging it in. So it's 1/4 8 squared minus 6 times 8 minus 4. 8 squared is 64 times 1/4 is 16 minus 48 minus 4. 16 minus 48 would be negative 32. Minus 4 would be negative 36. There aren't any units in this problem. They just didn't give you any, but the units would be something like meters per second or feet per minute. It's a velocity. So that's what we're looking for. So what did we do? To find the velocity of acceleration negative 2, we took 2 derivatives. That's acceleration. Made it equal to negative 2 to find our time, and then used that to figure out what the velocity was at that point. Questions on 7. Number 8 says a stone is shot with a slingshot vertically upward with an initial velocity of 50 meters per second from a height of 100 meters. Okay, so you got this position equation right here that shows you that stone being thrown in the air. Okay, find the velocity at t equals 2 and t equals 7. Do that right now with your neighbor. Go. So if we want to find the velocity at t equals 2 and t equals 7, Cam, what'd you do first here? Found the derivative. Yep, we're finding s prime of t, which we could call v of t. So we're taking the derivative of this thing, so times 2, negative 10. Subtract 1 from my exponent, so negative 10t. And then plus 50. That's velocity. We're finding v of 2 and v of 7. You take 2, you plug it in. So it's negative 10 times 2 plus 50. That's a 1, even though it doesn't look like it. That's 30. And then negative 10 times 7 plus 50. That's negative 20. It's negative 20. So the question is, explain the sign change. It changes signs. It goes from positive to negative. Anybody have a good reason for us having a sign change there? We take that ball, we throw it up, and it starts coming back down. Why do we have a sign change? What's happening? Luke? It's going up and then it's going down. So what does that sign change indicate? It's a change of direction. Wonderful. The velocity is positive when we're going up. The velocity is negative when we're going down. So since we changed from positive to negative, what happened? The stone, I guess I'm using a ball here, but it is a stone, changes directions. When velocity changes signs, that means your object changes directions, just like we would think if we threw a ball up in the air or a stone up in the air, what's going to happen? Okay. Question B says, when does the stone reach its maximum height, and what is that height? So for those watching at home, I'm about to throw a ball up in the air. Here we go. I'm throwing this ball in the air. Tell me now when this ball reaches its maximum height. Everybody ready, set, go. Oh, okay. No, it wasn't. You were way late. It was way earlier than that. Try again. Ready, set. Cool. One more time. Good. Right there, when it reaches that peak, that's its maximum. What is true about this ball right at its peak? Velocity is 0. When does the stone reach its maximum height? When the velocity is 0. For one moment in time right there, when it hits its peak, that velocity is 0 because it's changing directions. Our velocity is equal to 0 for one moment in time. So our question is, when does the stone reach its maximum height, and what is its height? So if I know that velocity is 0, talk with your neighbor, solve that question. Figure out what is its maximum height and when does it happen. So the question is, when does the stone reach its maximum height and what is its height? So we want to know when v of t is equal to 0. So we're going to take v of t right here, negative 10t plus 50, and do what with it? Set it equal to 0. Good. Take that, set it equal to 0. So I'm going to subtract the 50. And then divide by negative 10. Divide by negative 10. T equals 5. What does that t equals 5 represent? That is our time. That is our seconds. That is when the ball or when that stone reaches its maximum. The next question is, what is that height? We want to know what the height of the stone is at that point. What do we do to find that? Good. We want to plug into position because I want to know what the height is. How do I find the height? By the position equation. Okay, so we're going to find S of 5. I'm going to take 5 and plug it into this equation right here. If this was the AP exam and this was the question, I'd leave it just like that. I don't have to do any math. That's the great thing about calculus. Okay, but we could. 5 squared is 25 times negative 5 would be negative 125 plus 250 plus 10. That would be 135. What would my units be on that 135? Meters, because we plugged into position and position was in meters. Make sense what we did? We just kind of look at the situation, see what we're given, think about what we have to do to find an answer. All right, that's given an equation. Now on the back side, we've got to do this. We're doing some calculator practice. Okay, our next test that we're going to take will be our first test we take where we get to use a calculator for part of it. Okay, but you wouldn't use a calculator for this, right? I'm not going to give you a calculator question where that's why you need a calculator. You're going to need a calculator because you can't do it without one. Okay, so you have to be good at your skills with your calculator because you cannot do these questions without one. On the test, there are 9 multiple choice questions. 3 of them will be non-calculator, or will be with a calculator. Sorry, so not a whole part. Okay, but a little bit where you got to be able to do it without a calculator or with a calculator. All right, here we go. So it says a pendulum's position is modeled by S of t is equal to this thing right here, where S is measured in feet and t is in seconds from 0 to 4. Graph the marble's position over the indicated time interval. So that means use our calculator to figure that out. Okay, so let's do that. I turn on my calculator. Make sure you're in radians. If you're not in radians, if you're in AP Physics, you might have to switch. Okay, I'm going to hit the Y equals button, and I'm going to type in that equation. Okay, my equation here is 3 cosine 3t. So I just type it in. 3 cosine 3x, same difference. 3 cosine 3x. So 3 cosine 3x, we typed it in. Once we've typed it in, we want to look at the picture. So I'm going to go zoom 6. Zoom 6 gets us back to that standard zoom right here. That's what we want, zoom 6. I get that picture right there. It's a pendulum. Everybody know what a pendulum is? It's when you take it and it swings back and forth and back and forth. It would make sense that a cosine graph does a good job representing that because it's going to keep oscillating back and forth. Okay? In particular, that's too much because it said specifically we only care about 0 to 4. So again, I'm going to hit my window button. Here's my window button right here. Window. I'm going to go X minimum 0, X maximum 4 because that's what it told me to do. 0 to 4. I'm going to hit graph again. Boom, there's my picture. We don't need the graph for everything, but we're putting it in there because we're going to use it later as well. Okay? Question A says, find the pendulum's displacement in the first 1.5 seconds. We talked about displacement on Friday. What do we need to do to find displacement? It's our positions. We need to know our starting position and our ending position. Okay? I'm going to use my calculator to do all of that for me here. I want to know the position at 1.5, and I'm going to subtract from that my starting position. My ending minus my starting position, that's displacement. And I'm going to type that in my calculator just like that. Okay? So we're going to type that in. Let's do that now. So I'm here. I'm going to go second quick. Okay? I'm going to type that in just like I saw. I'm going to go alpha, F4, and I'm going to pick Y1. So again, look what I just hit. I went alpha, the green button. Okay? F4 up here on this top menu up there. I'm going to pick Y1 just like that. And I'm going to type it in inside of parentheses, that number that I have, 1.5. Close my parentheses. Minus. Do it again. Alpha F4. Y1. And in parentheses, I'm going to plug in the number 0. I'm doing exactly what I wrote in my paper. The position at 1.5 minus the position at 0. I hit enter. I get that right there. How many decimals do I need to round to? It is always 3 decimals no matter what. It is always 3. Negative 3.632. Great. We found displacement. Okay. Next thing we're going to do is find the pendulum's velocity. We're finding velocity. They gave me position. What do I need to do with position to find velocity? Take the derivative. Okay. The good news is this is a calculator question. So don't do it by hand. Okay. Right now, you don't know how to find this derivative anyways. We'll know how to do it tomorrow. But right now, we can't find that derivative. Okay. So what we need to do is use our calculator to find that derivative. What we need to write on our paper is this. S of t, position, S prime, the derivative of it is velocity. If they're grading my paper, they need to know that's what I'm doing. I need to make that connection that, hey, the derivative of position is velocity. Okay? And then eventually, I'm going to find velocity at 0.5 seconds. That's going to be our ultimate goal. So I need to connect. Hey, the derivative of position is velocity, and here's what velocity is at 0.5. So let's do that. Okay, we talked about this already earlier a couple weeks ago, but we're going to find the derivative. To find the derivative in our calculator, we hit the math button right here. Okay, here's the math button right here. We hit the math button, and then we're going down to number 8, numerical derivative. Number 8, numerical derivative. Right there, it's d over d something. So it's d over dx. In parentheses, we're going to type that equation. So for us, I'm just going to go hit alpha F4 Y1. And then for x is equal to, what is our x going to be equal to? 0.5. We type it in. We hit enter. There is my answer. That is the derivative at 0.5 seconds, negative 8.977. Always 3 decimals. This first one, that was measured in feet. Sorry, not meters, but feet, because that was displacement. This is velocity. Anybody think they know what our units are going to be here? Feet per second. We took a derivative, so we added a time unit to our denominator. Questions on B? Cool. We did that. Now we're going to graph velocity. So we didn't know how to take the derivative of velocity. They just gave it to me here. Okay. V of t is going to be equal to that guy right there. Let's type it in. So y equals, I'm not going to type in over y1. I'm going to type it in as y2. So for y2, I'm going to type in that derivative that they told me. Negative 9 sine 3x. we learned on earlier that the derivative cosine, oh yeah, that's negative sign. So that makes sense that would happen here. We got some other things happening as well. Okay, we type that in. We can now hit the graph button, and we can see what's happening with that. Okay? When does the pendulum change directions during the first 2 seconds? Okay, so I'm going to change my window. Now I'm not going to 0 to 4 anymore. Now I only want 0 to 2. Which one of those two lines is velocity? Which one would you type in, blue or red? The red one was velocity. If you don't know, you can hit the y equals. You can see, oh, yeah, it's red. Okay, but it's the red one that was velocity. Tell me now when that particle changes directions. Ready? Tell me now when it changes directions. There. Because what needs to be true for velocity or for a particle to change directions? Velocity changes signs. That's what we did in bell work. It's that spot right there. Okay? So if I want to find that, I'm going to go second. Calculate. What thing are we trying to calculate here? If I want to know when it changes signs, which one of those things do I want to calculate? The 0. Be careful. People want to say intersect. Intersect is when it crosses another line. Technically, it's crossing the axis. So because it's crossing the axis right there, we're going to do 0. Okay? We're going to pick that one. Notice right now that I'm moving on the blue line. I don't want to be on the blue line. I want to be on the red line. So I'm going to hit the down arrow. By hitting the down arrow, now it jumps to the other line. We could do other things with that in the future, but I'm just going to show you how to navigate. So I'm over here. Okay? So this is when I think it happens right here. It says left bound. So that just means I need to move to the left a little bit. I'm going to hit the left button a little bit and hit enter. Okay, it's going to put that little arrow on my screen. As long as that's to the left of where I want, great, I'm good. Now it says right bound, so I'm going to go to the right of that spot a little bit. Hit enter. It says guess. If my answer is somewhere between those two lines, I'm good. I'm going to hit enter a third time. Boom, there's my answer, 1.047. T equals 1.047. We need to write down what we did. We couldn't just write that as our answer. What happened that made that true? T equals 1.047 because of what? Velocity changes signs. That's what they'd be looking for here on the AP test. If this were a free response question, they would want you to write down because velocity changes signs and then our value. That's all we had to write. Not because velocity is 0, but because it changes signs. That's the key. Questions on C. Letter D says, what is the particle's position when S is at a minimum? Great. Here's that graph. Oh, we're talking about position. Now that's the blue line. I want to know when that blue line is at a minimum. Tell me now when that blue line is at a minimum. Yeah, right there. So we're going to go second, calculate. What are we going to calculate if we want to calculate a minimum? You guys are so smart. We're going to minimum. Again, here's where we think the minimum happens. Make sure you're on the blue line. If you're on the red line, you got to switch, but I'm on the blue line. Left bound, hit enter. Right bound, hit enter. Yes, hit enter. There's my value. Which thing do I want here? Oh, what? That X looks familiar. 1.047. Oh, yeah. That's when the particle changed directions. That's what we just found the last one. Think about a pendulum swinging back and forth. When is it going to change directions? When it goes from the furthest to the left and then starts going back the other way. So it makes sense that that right there is when the minimum happens, when the velocity changes directions. Okay? So when velocity changes directions or when it reaches a minimum, it's happening at the same time. What is it? That's our y value. It's -3. Okay? So what did I do? I found S at 1.047. I found what is the position at that spot. And what was it? It was -3. That would be -3 feet because it's the particle's position. Pendulum's average acceleration. I want to know average. You hear the word average. What are we thinking right now? Average means 2-point slope. Average rate of change. It is a 2-point slope. What are we going to find a 2-point slope of? What, when we find the slope of it, is going to tell me acceleration? Velocity. I need to do a 2-point slope of velocity. The good news, on our calculator, that's really easy. 2-point slope. I'm going to do a fraction. On bottom, it's my 2x values, 0.5 minus 0. On the top, it's my 2y values. So that is velocity at 0.5 minus my velocity at 0. The 2-point slope of velocity will tell me average acceleration. The slope of velocity tells me acceleration. All we got to do is type that into our calculator. So to type that in my calculator, second quit. I'm going to hit alpha F1 because if I'm typing in a fraction, I want to use the fraction button. Alpha F1, I'm using my fraction button. On top, I'm going to just type it in. I don't want to find that number early. I'm going to round it and mess it up. So instead, I'm going to go alpha F4. Which one of those buttons am I using after I do alpha F4? Y2, because I want to find velocity. Velocity at 0.5. Close it. Minus alpha F4. Y2. Velocity at 0. Close it. Over. 0.5 minus 0, technically 0.5, that's x sub 2 minus x sub 1. Y sub 2 minus y sub 1, x sub 2 minus x sub 1. 2-point slope. Everybody with me there? Hit enter. Negative 17.955. This was average acceleration. Anybody got a unit for me? It is feet per second squared. I'm doing acceleration. That's the second derivative. Second derivative means 2 time units in our denominator, at least so far. Everybody with me there? There's a lot going on right now. I'm introducing a bunch. But again, we got 5 days to review later on. We're putting a lot on us now. That way we can do more as we go soon, or as we continue through. Find the acceleration at 0.5 seconds. Right now we've got velocity. What do we need to do with velocity to find acceleration? Derivative. You're going to find v prime of t. That will tell you acceleration. V prime at t will tell me acceleration. That says v prime, I swear. V prime of t is equal to acceleration. And then all you got to do is find acceleration at 0.5. Again, you need to make sure that you've written this on your paper. That way, whoever's grading your paper knows that you understand what the derivative of what acceleration is. It's the derivative of velocity. Find that in your calculator. Go. Here we go. To find it, we're going into our calculator. Math 8, numerical derivative. dx alpha F4 y2, because I want to take the derivative of velocity at 0.5. We hit enter. Negative 1.910. Negative 1.910. Again, that would be feet per second squared because I'm talking about acceleration. A lot of calculator skills you need there, but if you can do those skills, you can do almost everything we need to do this year with our calculator.